Hello, everyone. Uh, I'm going to discuss the first example on 2.5 in more detail and work through the problem step by step. And the example here is evaluate the limit of the function f as x approaches 0. And the function f is defined piecewisely. So fx is equal to x minus 1 if x less than 0, and fx equals x plus 1 if x is greater than or equal to 0. So it's more convenient to draw the graph function when you try to evaluate the one side the limits or the limit of function. If you don't feel comfortable about the algebra. This section is about one side the limits. So we need to understand piecewise defined functions. This is a typical piecewise defined function. If you draw the graph, you can see there are two pieces for the function. One piece on the left of the y-axis and one piece on the right-hand side of the y-axis. Remember, when you try to graph the function, you have to consider piece by piece. Okay, so why do we know there are two pieces for the function? Because we know there are two expressions defined for this function. And one piece is for x less than 0, so that's the left-hand side of the y-axis. And it is defined as fx equals x minus 1. So if you draw the graph of fx equals x minus 1 on the left hand of the y-axis on the xy plane, you're going to see a straight line with 45 degrees to the x-axis, and the x-intercepts, the y-intercept, I'm sorry, for the function is -1. Okay, so -1 is y-intercept, and 1 is the slope, right? But because in the definition of the function, we don't have equal sign here, so this is valid only for x less than 0, not equal to 0. So the point on the y-axis of this part of the curve should be ruled out. So that's why we use the open circle in the graph. That means the point of -1 on the y-axis is not included in the graph of the function. Okay. And the right-hand side of the function is defined as fx equal to x plus 1. So that's again the slope is 1 and the y-intercept is positive 1 this time. So it is a straight line again, 45 degrees to the x-axis, but the y-intercept is 1, positive 1 instead of -1. And this definition is valid for x greater or equal to 0. So what it means is x equal to 0 should be included in the graph of the function. X equal to 0, that means the point is on the y-axis. Remember, the x coordinate of the point on the y-axis is 0. Okay, x equal to 0 means a point on the y-axis. So the y-intercept is positive 1. That's included in the graph of the function on the right side of the graph. So understand the problem itself sometimes takes time, but it's the first step and a very important step to start. So now let's come back to the problem itself. We need to evaluate the limit of function as x approaches 0. So because the function is defined piecewisely, especially at x equals 0, we got two different curves on the left and on the right side. So that indicates that we need to evaluate one-sided limits. We need to find the left-hand side limit of the function and the right-hand side of the limit of the function. In order to find the limit of the function itself as x approaches 0. So let's just do the left side limit for the function, okay? So we use negative sign to denote we are talking about the left-hand side. Okay, so the left-hand side limit of the function as x approaches 0, we use x approaches 0 minus, but the minus sign should be on the shoulder of 0. Okay, so let me try to find where to for the superscript. Okay, so, oh, wait, sorry about it. So this should be, okay, it's not, that's not what I want. I don't know why. Okay, let me try it one more time. Oh, let's put the superscript here. So that doesn't work. Okay, let me find where the notation is. Okay, so let me just use the notation here. Copy it. Okay, so we're trying to find the left side limit first, and then we're going to find the right hand side limit. So the notation is x per 0 minus on the shoulder of 0. That means the left hand side limit of function f as x per 0, or the left hand side limit of the function. So when we do that, we need to consider the left hand side of the function. So on the graph, we need to look at a curve on the left hand side. So as you can see, when x approaches 0 from the left, okay, so the points on the curve moves on the lower line, right? So when x approaches 0, okay, so what it approaches? The function value or the y value of the function approaches -1. And this open circle is actually the limit point as x approaches 0 from the left. And when we talk about the limit of a function, we mean the function value it approaches. So the function value approaches -1 from the left. So then we conclude the left-hand side limit is -1. Okay, so that's equals -1. So that's the left-hand side limit. Left-hand side limit is, sorry, is what? Is -1. And with the notation of this, okay. So we use the notation, limit of f as x approaches 0 minus equals -1, not 1, sorry. So that's the left-hand side limit. We can also do the same thing for the right-hand side limit. So this time, we need to look at the curve on the right. So that's the upper line. So again, the right-hand side limit of the function as x approaches 0 from the right. Okay, x approaches 0 from the right. So the curve is the upper line, and we need to move the point on the upper line to the y-axis. And this time, the limit point is the closed points on the upper half plane, and the y-intercept is 1. So when x approaches 0 from the right-hand side, the y value or the function approaches 1. So the right-hand side limit of the function is 1. And with notation x approaches 0 plus, equals positive 1. So we can put a similar statement, but this time is right-hand side limit instead of left. So these are the one-sided limits. Then the original problem is to ask the limit of function as x approaches 0. We already found the left-hand side limit and the right-hand side limit. Okay, this should be 1. And then we compare them. And they're not the same. One is -1 and the other is +1. So when they are not the same, that means, the function approaches different values from the left and from the right. So the limit does not exist. They approach different values from the left and from the right. So the function does not have a limit, or formally, the limit of the function as x approaches 0 does not exist. Since left-hand side limit of the function as x approaches 0 is not equal to, okay, not equal to the right-hand side limit of the function. Does not exist. Okay, so so use the notation of limit. So we have the limit of function, the limit of f as x approaches 0 does not exist. All right. So that's the conclusion.